Hi, everyone. So we are starting our lesson now, and this is the third revision class of Year 5. And it's going to be on the calculation of negative numbers and decimals. So I believe that most of you must have learned about these before. So the reason why we're holding this revision class is just because that we find that some of you are not doing really well in the negative numbers calculations or the decimal calculations, which is the reason why we're just going to re-emphasize these calculations again. So basically, the addition, subtraction, multiplication, and division of negative numbers and those of decimals. This is what we're doing today. And once we're done, we're done. Okay, so I hope you're all with me, and we will start our lesson now. So first of all, before we move on to any negative number calculations, there is one definition that we need to stress, which is the opposite numbers. The opposite numbers. So what does opposite numbers mean? Basically, if I have a number line, so that's going to be in the positive direction, and say that is 0. Opposite numbers actually means reflecting a number about 0. So considering 0 as, like the mirror line or the mirror point on the number line. So if I have, say, for example, 3, the opposite number is going to be -3. Or, of course, the other way around. If I have -3, the opposite number is going to be, the opposite number is going to be 3. Okay, so these are the definition of opposite numbers. And how we find the opposite numbers is just by adding a minus sign in front of the number. For example, what is the opposite number of 9? That's just going to be adding a minus sign in front of 9. So it's -9. And what is the opposite number of -4? Well, we know that from intuition that it's going to be 4, right? But actually, when we are looking for opposite numbers, first of all, we should write it as -4. Yep. So that's how we do it. And actually, well, because we know that by intuition, the opposite number for -4 is definitely 4. So it means that actually -4 is equal to 4. And of course, the same thing for -12 is going to be -12. All right. So that's going to be equal to 12. And for 7, the opposite number is -7. So now we can see a rule here, which is if I have 2 minus in a row, that's going to be a plus. Okay. So now let's try to take a look at the following questions. So if I have +8, Kathy, I would really want you not to do the annotations. Thank you. So if I have +8, well, I can see that that is pretty much positive. So this is going to be 8. That's equal to 8. But if I have +15, what is the value of +15? That's actually going to be -15. And what is -4? It means that that is the opposite number of +4, which is -4. And for -6, we have just learned about it. If I have 2 negatives in a row, that's going to make a 6. That's going to make a positive. So now we can make a conclusion if I have 2 same signs or 2 same operations. Yes, Kathy, do you have any questions? If you have any questions, you can type it in the chat box, all right? If I have two same signs, that's going to be equal to a positive outcome. If I have two different signs, that is leading to a negative outcome. All right. So that we are talking about the addition or subtraction in front of a number. So if I have two same signs in front of a number, that's going to be a positive. If I have two different signs in front of a number, that's going to be a negative. All right. So there's only these two cases. And by two same signs, I mean either 2 plus or 2 minus. Both of them will give us a positive number. Okay. So if we're all good, then let's move on to a little bit of calculations. So what is plus minus 12? Are they two same signs or two different signs? Well, obviously they're going to be different, right? Yep. So if we have two different signs, it's going to lead to a negative outcome. Okay, it's going to lead to a negative outcome. Yep. And what is positive 20? Are they two same signs or two different signs? That's okay, Helen. And yes, there are two same signs. So it's going to be a positive outcome. And what about minus plus 33? Are they two different signs or two same signs? Yes, different. Of course, they're different, right? So two different signs will give me a negative outcome. So it's minus 33. And what about minus 36? Minus 36. Do you think it's going to be a positive outcome or a negative outcome? Yeah, that's right. That's right. Because I have two same signs right here, two same signs. It means that it's going to lead to a positive outcome, which I know that for positive numbers, I don't need to write the plus necessarily. I just write it as it is. So it's 36, which is equivalent to plus 36. Yes, of course, Andy. All right. So now we are sure about the opposite numbers, and hence we can move on to a little bit of addition and subtraction. Okay, addition and subtraction. So how do we understand the addition and subtraction when it comes to negative numbers? First of all, we can try to use a number line to help us. So for example, negative 5, we know it's going to be 5 smaller than 0, yeah? And when we are adding 3 to a negative number, we know that whenever we are adding 3 or adding a number, it is going right on the number line, yeah? So when we are adding 3, actually, it is moving 3 closer to 0, which means that it's going to be ending up with negative 2. All right, so we are not adding 5 to the 3. We are just adding 3 to negative 5, which means that it's going to move 3 numbers closer to 0, okay? And if I'm taking away 3 from negative 5, we know that when I'm taking away a number, it goes left on the number line, right? It goes left on the number line. So since negative 5 is already on the left of 0, it means that taking away 3 will mean that, well, it is shifting 3 numbers away from 0, or from actually like away from 0, starting from negative 5. So negative 6, negative 7, negative 8. And the answer is negative 8. Okay. So when you're doing some, like negative number calculations, if say you haven't done these kinds of negative number calculation before, well, a great start would be that you can try to use the number lines to help you. Try to mark the numbers, say, for example, negative numbers or any other numbers you have on the number line, and use the number line to help you think about whether it is moving closer to 0 or further away from 0. Okay, so that is going to help if you are starting to do negative number calculations. Yes, of course, Hugo, that's fine. All right. And next, sometimes we are adding a negative number or subtracting a negative number. So what should we do when we are adding or subtracting a negative number? The first thing is just try to simplify this expression first. Previously, we have learned about opposite numbers, right? Which if I have two same signs, it's going to be positive. If I have two different signs, it's going to be negative. Yep. So right here, we can just try to take this part out and see whether it is actually positive or negative. Say plus minus 4. Do they have the same signs or different signs? Yeah, they have the different signs, of course. We all know that. One of them is plus, one of them is minus. So if I have two different signs, it will give us a negative outcome, which means that plus minus 4 is actually equal to minus 4. So that's equivalent to minus 5, take away 4, which means that it's going 4 down on the number line. And that leads to minus 9. Okay. And what about negative 5 minus negative 4? So just like what we did just now, we can take the whole thing right here and try to simplify it. So now if I have two same signs, is it going to be a positive value or a negative value? Positive. Yes, that's right, positive. So it's going to be adding 4. So if I'm adding 4 to a number, I know it is moving right on the number line, which means that, yeah, after adding 4, minus 5 will go to minus 1. So the answer is minus 1 for this question. All right, does it make sense? So now we can try to do a little bit of calculations. For example, 20 take away 100. So what we can do is that we can first draw a number line. So this is going to be 0, this is going to be 20. If I want to take away 100, it would be equivalent to taking away 20 and then taking away another 80, right? So taking away 20 leads to 0, taking away another 80 will lead us to minus 80. So the answer is minus 80. And then the next one, minus 8 adding 8. So again, we can try to use the number line to help us. Minus 8 is where we start. So let's say this is minus 8, and that is 0. So for adding 8, we know that it's going right on the number line. Yeah. So it means that it's going to add 8 on the number line, which is moving 8 closer to 0. And obviously, that's going to end up with 0. Okay. And for the third one, minus 20 adding 15. So let's say starting from minus 20, and that's 0. Adding 15 means that it's going on towards the right on the number line. So it means that I'm moving 15 boxes closer to 0, which means that if I take away 15 from 20, I know this is going to be minus 5. Okay. And next I have minus 2 take away 8. So this is 0, this is minus 2. If I'm taking away 8, So it's definitely moving to the left on the number line, right? So taking away 8 means that moving 8 boxes to the left, which means that we are moving 8 boxes further from 0. So that's going to add up to a total of 10 boxes away from 0, which has the value of -10. Yes, that's right. And -65 adding 15, well, we just do the same thing. If this is -65 and this is 0, if we are adding 15, it goes to the right. It moves 15 boxes closer to 0. So, well, we know that that's going to be having a value of 65 take away 15, which is 50. And of course, it's still not reaching 0 yet. So we need to add a minus sign in front of it. And finally, 0 take away 5, which means that starting from 0, we are moving 5 boxes away from 0. So that's going to be -5. Yes, Ashley, do you have any questions? If you do, you can just type it in the chat box, okay? Sorry, we're having a really large group today. We have something like 37 of you. I really do appreciate that, because everyone I know, this is, well, 38, that's including me. So yeah, I really do appreciate that. 37, yes. 38, that's including me, Anthony. So, well, I know this is the Sunday evening for you. So I really appreciate that you come to my lessons. No. Because we know that moving to the right, if I'm adding 15, Ashley, if I'm adding 15, it's moving to the right, which means that it's moving closer to 0, right? So it's less negative. All right. So more of these calculations on the next page. But on this page, what we need to do is that we need to simplify these expressions first. We need to simplify these expressions first. Sorry about that, Xichen. These are revision classes. So how hard would you expect the questions to be? All right. So plus -6. That's different signs. So does it end up with positive or negative values? If they're different signs, that's going to be a minus, right? So that's equivalent to -3 take away 6, -3 take away 6, which is, well, take away 6, that's definitely moving further away from 0. So that's -9. And the next one, that's going to end up with -47, because they have different signs. So if I take away 47 from 35, if I take away 47, it's going to be equivalent to taking away 35 first, such that it reaches 0, and then taking away another 12, right? So it moves to -12. Okay. And the next one, -5 take away -9. So what is this going to add up to? Well, two same signs this time, two same signs, two minus in a row, which means that it is going to be equal to adding 9. So if -5 is adding 9, it means that it's moving to the right for 9 boxes, which we can split it into 2 sections, adding 5 first, such that it reaches 0, and adding 4 again, so that it reaches 4. Okay, so the answer is going to be 4. Yeah, that's right. That's right. And then for the next one, minus 23 take away minus 11. So again, we can just simplify this because they have two same signs. It's going to be adding 11, which means minus 23 adding 11. It's moving 11 closer to 0, so that's going to be minus 12. All right. So we can always use the number line to help us finish the calculations. And for the next two, well, we don't actually need to number line anymore because that's going to end up with adding 25. 13 adding 25, definitely 38. And the last one, that's adding 52. 0 adding 52, that's 52. So we don't need the number line anymore. Okay. So now I believe you can do all the additions and subtractions related to negative numbers. So basically, if you see any more numbers in the addition and subtraction, you just need to do those one by one. Okay, so you don't need to worry about it at all. So after the addition and subtraction, what are we assuming next? This is going to be the multiplication and subtraction, or a multiplication and division of decimals. Okay, so for the multiplication of decimals, no, not decimals, negative numbers. Sorry, I got mixed up. For the multiplication of negative numbers, so how we may observe it is by understanding the meaning of multiplication. So the meaning of multiplication is adding something for a number of times, right? For example, if I'm multiplying 3 to 3, it means that 3 is added 3 times. Yeah. So 3 adding 3, that's 9. And if I'm having 3 times 2, it means that now I'm just adding 2 of the 3s, which means that definitely it's going to be 3 less than 3 times 3, right? And if I keep counting down, 3 times 1, that will be 3 less. 3 times 0, that would be 3 less. What about 3 times minus 1? So minus 1 is 1 less than 0, right? So definitely 3 times minus 1 will be 3 less than 0. So 3 times minus 2 will be 3 less than minus 3, which is taking away 3 from minus 3. That moves minus 3 numbers further from 0. That goes to minus 6. And for the last one, again, we take away 3 from minus 6, and that ends up with minus 9. So you can see that, well, in 3 times minus 1, 3 times minus 2, and 3 times minus 3, it's just like 3 times 1, 3 times 2, and 3 times 3, except that the sign has changed, right? Except that we have a minus sign in front of these numbers. Okay, so now we know that if I'm multiplying a number, a positive number to a negative number, I get a negative product. Okay. And what if we are multiplying a negative number to a negative number? Yeah, that's right. That's the question. What if there are two negative numbers multiplying to each other? So now let's remember the last conclusion, okay? 3 times minus 3 is minus 9. And let's move on to the next page. So this is what we get from the last page, right? 3 times minus 3, that's minus 9. So according to the definition of multiplication, negative 3 multiplying 3 will be 3 of the negative 3s, right? So if I'm having 2 of them, it's going to add 3. Does it make sense? Because now I am just having 2 of these negative 3s. which means that I am adding 3 to cancel out one of them, right? So if I'm having -3 times 1, it will be adding another 3, such that it's just -3. And if I have -3 times 0, I will be adding another 3. So -1 is 1 less than 0. So definitely the next one is going to be minus another 3. No, adding another 3, such that it becomes a 3. So from 0 to 3, and you can see that's how we can multiply two negative numbers together, which means that if I have -3 multiplying -2, it's going to be adding another 3, such that it becomes a 6. And for -3 multiplying another -3, it's going to add another 3, such that it becomes a 9. All right. So from these numbers, we can see that that's exactly the same as 3 multiplying 1. And 6 is exactly just 3 multiplying 2. Well, but it is the same as -3 multiplying -2. So what can we say about this? Just like previously when we did the opposite numbers, actually, when we are doing multiplication or division, in multiplication or division of negative numbers, again, if I am multiplying or dividing numbers with two same signs, the outcome is always going to be positive. Okay, so if I'm multiplying or dividing the numbers with two same signs, for example, minus and minus, or of course, plus and plus, that will just be 3 times 1, right? I always get a positive outcome. And if I have two different signs, I always get a negative outcome. Yeah, very much like it. So very much like the opposite numbers, the rules are the same, but then this time we are doing multiplication or division. So if I have two same signs multiplying together, you get a positive. If you have two different signs multiplying together or dividing each other, you get a negative. All right. So now let's take a look at these simple questions. The first one, -5 times 6. Do they have the same signs or do they have different signs? Yeah, different. So two different signs, what does it mean? It means that the outcome is going to be negative. So let's put down the negative sign first. And what about the value? What about the value? The value is just 5 times 6. That's 30. All right, so the value never changes. What changes is the sign. Okay, so the sign is the only thing that changes from the positive number calculations when you're doing multiplication or division. It's only that the signs are changing. Okay, so the next one might be a little bit tricky. I have two minus in a row and I'm multiplying to 7. So what do we do first? If I see two minus in a row, so what I should actually do when I see two minus in a row is that, of course, I will need to simplify this number first because I don't want so many signs together. So for this -4, I know that two same signs makes a positive. So it's going to be +4 multiplying 7. So positive 4 multiplying 7, that's going to be having the same signs, which means that, well, it's just 4 times 7, isn't it? So it's 28. So that's 28. And finally, if I have minus 8 multiplying minus 12, definitely I have two same signs. So what is the outcome going to be? Is it going to be positive or is it going to be negative? That's right, that's right. If I have two same signs, the outcome is always positive, and the value will just be 8 times 12. That's going to be equal to 96. All right, well done. I can see that you all understand it. You all remembered it. But make sure that you didn't just remember it for this lesson. Make sure that you remember it always, okay? Because like this is kind of important, these negative number calculations. So it's going to be, you know, like following you through all stages of mathematics studies. All right, I can see many of you raising your hand for some reason. If you have anything you want to ask me, could you just type it in the chat box? Thank you. All right, so next on, we are doing some divisions with negative numbers. Okay, so minus 72 divided by 8. Is that having same signs or different signs? Different signs, right? So for different signs, we know that the outcome is going to be negative. So we put down a negative right there first. And after that, what do? We divide 72 by 8. So that's going to be 9. So dividing 72 by 8, that's going to be like dividing minus 72 by 8, that's going to be minus 9. Okay. And next, minus 999 divided by minus 37. So are they having same signs or different signs? Same signs. So is the outcome going to be positive or negative? Yes, very good. Very good. It's going to be positive. It's going to be positive. If I have two same signs, it's always going to be positive. Okay. So I have a positive outcome, which means I don't need to write any signs there because positive numbers are just like the numbers we use daily, which means I'm just calculating 999 divided by 37. And what is that going to be? So we know 37 times 3, that's 111. And 999 is 9 times that. So it's going to be equal to 3 times of 9, that's 27. Okay. And finally, 102 divided by minus 17. Do they have same signs or different signs? Different, of course. So is the outcome going to be positive or negative? It's negative. Negative, that's right. So 102 divided by 17 will be the value, and that's going to be a 6. So the answer is minus 6. Yes, that's right. Okay, so that's everything we have to do for negative numbers. I guess that would be pretty easy for the most of you, because I guess you might have more or less learned about these before. So now let's move on to the decimals. Let's move on to the decimals, okay? All right. So for the decimal addition and subtraction, the most important thing that we need to do, the hard bit, not really. It's just decimal calculation. How hard can that be? So in addition and subtractions of decimals, the only thing you need to remember is to align the decimal point when you are doing the addition and subtractions. For example, 4.5 adding 3.2, we just write it like that. And remember, aligning all the decimal points, which means that there should be a decimal point in the answer as well. So now I'm just adding 5 to 2, that's 7. 4 to 3, that's 7. So the answer is 7.7. All right. Yeah, that's right. And what if I'm doing the subtraction? It's just the same. If I am taking away 0.4 from 1.2, I am aligning the decimal point all the way through the answer. So now I'm taking away 4 from 2, which means, well, I need to borrow a digit from 1, and 1 becomes a 0. So now 12 take away 4, that's 8. 0 take away 0, that's 0. So the answer is 0.8. So don't forget about the decimal point, okay? Yeah, that's right. The decimal points should be aligned. And what if I'm adding 8.92 to 24.3? That's just the same. So if I have 24.3, decimal point is right there. So I should write 8.92 like that when I'm adding it. Now, for the answer, the decimal point is also aligned, right? So there's nothing on top of 2 in 24.3. If there's nothing, then it's just going to be a 0, right? So that's a 0. A 0 adding a 2, that's going to be a 2. A 3 adding a 9, that's going to be a 12. So I'm writing the 1 here. 4 adding 8 adding 1, that's 13. 2 adding 1, that's 3. So I have 33.22 as the answer. Yes, that's right, 33.22. Very good. And the last one, 32.4 take away 15.77. So we just do the same thing. We always just align the decimal point when we are doing addition and subtraction of decimals. All right, not any other operations, just the addition and subtraction. That's when we need to align the decimal point. All right, so we are taking away 15.77. So as I said previously, if there's nothing on top of 7, nothing would just be 0. Nothing would just be 0. Okay. Yes, Helen, of course, I will talk about that later. Don't worry. So we are still now at addition and subtraction. We haven't moved on to the multiplication and division yet. Of course, Hugo. That's right. It doesn't really matter how you pronounce it anyways. The reason why I pronounce it as 15.77 is just because, well, you know, it's kind of easier to pronounce it, but yeah, probably the better way to pronounce it is 77. So we take away 7 from 0, which means that I'm gonna borrow a digit. So yeah, just do the aligning, make sure that you have the decimal point all along. And 10 take away 7, that's gonna be 3. 3 take away 7, so I need another borrowing from the higher place. 13 take away 7, that's 6. 1, oh, so I need another borrowing again. 11 take away 5, that's 6 again. 2 take away 1, that's 1. So I have 16.63 as the answer. Yes, that's right. That's right. It's 16.63. Okay, so that is everything about the addition and subtraction of decimals. Are we all good? Okay, so now we are moving on to the multiplication of decimals. So for the multiplication of decimals, here is how it works, okay? So listen very carefully. First of all, we just multiply 9.8 with 1.03. So it doesn't really matter which one you put first. Personally, I would like to put the longer number on top. So this time we don't need to align the decimal point anymore. We just calculate it just like 103 multiplying 98, okay? So probably we can start from the ones place, or if you like, you can start from tens place, doesn't really matter. So 8 times 3, that's 24. 8 times 1, that's 1. So now I put a 0 there. 9 times 3, that's 27. 9 times 1, that's 9. So I add them up, it's going to be 4, a 9, a 10, another 10. So 10094. And then we just need to count the number of digits after the decimal points in total. So this is one decimal point, like it has one decimal place, and this has two decimal places. So altogether, it's going to have 3 decimal places in the answer. So I just count 1, 2, 3, and put the decimal point right there. So the answer is going to be 10.094. Yeah, that's right. So basically, in the multiplication of decimals, the first step is just to multiply without decimal points. The second step is to add the number of decimal places. And the third step is to put the decimal places back to the product. Okay, so multiply without decimal points first, and then add the number of decimal places in the two multipliers. Finally, the sum, which you get in the second step, put the decimal places back into the product. That's it. All right. So for the next question, 4.8 multiplying 0.25. So let's calculate 48 times 25 first. So for 48 times 25, we know that's going to be equal to 4 times 12 times 25, which is 12 hundredths. That's multiplication skills. Yeah, that's right. So then the next step, second step, we add the number of decimal places. So I have got 1 decimal place here. I have got 2 decimal places here. Altogether, that's 3 decimal places. So 3 decimal places, 1, 2, 3, that's where we put it. So the answer is going to be 1.2. The answer is going to be 1.2. And the reason why I don't need to write the 2 zeros is because that these 2 zeros are on the very right of the right-hand side of the decimal. So I don't need to write them because they are basically meaningless. So writing them or not writing them, it gives us the same number. So I don't necessarily have to write them. Of course, writing them doesn't mean that you're wrong. It's just more proper if you take it away, okay? And next we are doing 0.32 multiplying 0.8. So first of all, we can do 32 times 8. That's going to be 8 times 2, which is 16. 8 times 3, that's 24, so 256. Now on the left-hand side, I have 2 decimal places. On the right-hand side, I have 1 decimal place. So altogether, there should be 3 decimal places again. But now, 1, 2, 3, it goes right there. So can I just write the answer as 0.256? It doesn't really look like a number. It doesn't really look like a proper number to me, because if I want a decimal, it needs to have the integer part and the decimal part, right? But now, obviously, this decimal is missing the integer part. But it looks to me that it doesn't have an integer part. So if it doesn't have an integer part, we just put 0 for nothing. There's nothing in the integer part, so we put down 0. So it's actually 0.256. Yes, that's right, Hanlin. You need a placeholder. So you put the 0 right there as a placeholder. Good. And finally, 0.32 times 1.2. I believe you can all work it out. So 32 times 1, 2, which is 12. That's going to be 2 times 2, that's 4. 2 times 3, that's 6. So I put a 0 there and 32. And I add them up. That's going to be 4, 6, 3. So 364. Now I just count 2 decimal places on the left, 1 decimal place on the right. So altogether, again, we have 3 decimal places altogether. So counting 3 decimal places, it ends up there. So 0.364, we know that isn't right. So we just put a 0 as the placeholder. Okay, so 0.364. Oh, 8. Yeah, that's right. Sorry about that. I am getting a little bit old. Thanks for reminding me. Yep, that's 4, 8, and 3. Sorry about that. And of course, we just trace it back and put the decimal point there. 384. Thank you, everyone. Okay, so that's everything about multiplications, all right? So finally, we are doing the division of decimals, which is actually the hardest of all. Yeah, I'm somewhere around 20 to 30 years old, but obviously I'm older than you. So you can imagine that my calculation skills might be worse because, you know, I'm getting old and my brain is getting slower than before. Well, yes. Well, it's either the bus stop method or like the long division. So basically, first of all, before we learn about the division of decimals, let's establish one thing. For example, what is 2 divided by 1? Yeah, that's right. 2 divided by 1, that's 2. So if I am multiplying 10 to the 2, such that it becomes 20, how may I get a 2? What operation should I do to 1, such that after dividing that number, I still get a 2? Yeah, I know this is going to be 10, so that's multiplying 10 as well, right? So actually, you can see that in a division, if you are multiplying the same number to the dividend and the divisor, you're going to get the same quotient or the same answer. So basically, you just need to multiply the same number to both the dividend and the divisor, and you get the same answer or the same quotient. Okay, so once we establish that, the first step of any decimal division is going to be turning it into a normal division by multiplying the same number on both the dividend and the divisor. So how may I do that? I just need to multiply it by 10. For example, after multiplying 10 to 16.8, I'm going to have 168. So it's an integer now. It's an integer now. Yeah, that's right. And we know that in order to get the same quotient, I need to multiply 28 by 10 as well. So that's 280. So now I am dividing 168 by 280. And how am I supposed to do that? How am I supposed to do that? Well, I don't have enough to divide. So all we need to do is to just add a few zeros behind that. Well, just add any number of zeros you want, making sure that might be enough. So then we align the decimal point here, and we can start doing it just like any normal long division. Okay, so first of all, if I'm dividing 168 by 280, I know that's going to be a 0 right there. So what I have is 0, right? And the next place, 1,680. So now you're taking the 0 into account as well. 1,680 divided by 280. So that's probably going to be 7. Such that 0 multiplying 7 is 0. 8 multiplying 7 is, well, 7 is too big. Nope. I can't have a 7. So that's probably like, say, 5 or 6. Actually, maybe 6. So 0 times 6 is 0. 8 times 6 is 48. 2 times 6 is 12. Oh, so that's 1680. So now I have completed it, right? So it turns out I don't need so many zeros, so I can take those away. And how I get the answer is by reading the quotient right here. So that's going to be 0.6, 0.6. So make sure that when you're adding the zeros, you add the decimal point and you're aligning the decimal point in the quotient. So that's how you can get the answer, 0.6. Okay, so the first step is to turn it into a normal, or let's not say normal because that is very ambiguous, into an integer division. The second step is for the dividend, add decimal point and zeros after the dividend. Nope. Dividend. And the third step is to align the decimal point in the quotient and finally just divide it. Okay, so that's the reason why it is more complicated than any other operations before, because it requires many different steps and sometimes we can't be sure. For example, I don't know how many zeros I should put in. So now let's take a look at 2.5 divided by 0.4 following these steps. First of all, we should turn it into an integer division by multiplying the same number of tens on both sides. So if it multiplies by 10, I get 25. If 0.4 is multiplied by 10, I get a 4. So it becomes 25 divided by 4. So now I'm working on 25 divided by 4. So 25 divided by 4, I get 4 times 6 is 24. And I get a remainder of 1. But actually, I don't want a remainder. So I'm just putting a few zeros behind. And this 0 drops down to a 0 right here. And remember, align the decimal point in the quotient. So now 4 multiplying 2, that's going to be 8. So I have a 2, and I drop this 0 down. So 4 multiplying 5, that's going to be 20. So now I have my answer, which is 6.25 or 6.25. And for section C, 4.2 divided by 0.25. If I multiply 10 to 4.2, it's going to end up with 42. If I multiply 10 to 0.25, it's just 2.5. So, well, I still have a decimal. Which means that, oh no, Joshua, it's 6.25, not 0.625, because you need to mind where the decimal point is, okay? And right here, 42 divided by 2.5, that's not an integer division yet. So I need to change this into an integer by multiplying another 10, which means that I'm actually looking for 420 dividing 25. All right. And that is going to be, well, let's say 420 divided by 25. So first, I have 1 there. So it's 25. And now I'm taking that away, which means that it's going to be 17. And I drop the 0. So next, say probably I'll do a 6, such that 5 times 6 is 30. 6 times 2 is 12, so it's 150. So I have 20 remaining, which means, again, I don't want any remainders. So I am adding a few zeros and aligning the decimal point right there. So I can keep dropping the 0. 200. So 25 times 8, that's 200. And that's how I finished the calculation. So this 0 is unnecessary. Now I have got my answer, 16.8. Okay, so that's how we can complete a decimal division. Always, you need to turn it into an integer division first, and then you just add the decimal point when it's not enough. Add the decimal point whenever you have a remainder, such that you can continue with the dropping of zeros to continue with your divisions. And then you need to align the decimal point if you're adding any zeros, align the decimal point in the quotient as well, so as to make sure that the place is right. And finally, you can just divide it step by step, like any long divisions. Okay, so this is how we do the division of decimals. Okay, so we have learned about all the addition, subtraction, multiplication, and division of negative numbers and decimals now. So just a quick conclusion for the negative number calculations. Well, first of all, always try to simplify the opposite numbers by the principle that two same signs give you a positive, two different signs give you a negative. And if it is an addition or subtraction in negative numbers, you can just use a number line to help you. If you're adding a positive number, then it's going to be moving right on the number line. If you are subtracting a positive number, it's going to be moving left on the number line, okay? And for the multiplication and division of negative numbers, you just need to pay attention to the signs. So the value is always going to be the same, but the signs can be different. Just following the same principle, if you're multiplying two numbers with the same sign, it's going to be a positive. If you're multiplying two numbers with different signs, it's going to be negative. Okay, so that's the conclusion for negative numbers. As for the decimal numbers, as for the decimals, calculations of decimals, if you're doing addition or subtraction of decimals, just do it as any long addition or subtraction you did before, except that you need to align the digits, which means that you need to align the decimal point, okay? And if it is multiplication, you can just do the multiplication first without the decimal point, and then count the decimal places, add them up, and put it back to the product. As for division, just like I said just now, you need to turn it into an integer division first, and then you just try to divide it. And if you have a remainder, you just need to add the decimal point, align it with the quotient, and add some zeros behind to continue your division. And later you can just carry on as a long division. But when you are taking the quotient finally, just remember that there is a decimal point there, which you shouldn't forget. Okay? So that is going to be everything for today. Does anyone still have any questions for me? All right, very well, very well. So in that case, no problem, Leon, no problem. In that case, this is going to be the end of the lesson today. Thank you all for coming, and I wish you a nice Sunday evening, or what's remaining of it. All right, thank you everyone, and bye-bye. I will see you in the summer holiday lessons. Bye-bye, Rachel, thank you. Bye-bye, Helen. Bye-bye, CC. Bye-bye, Mina, Daniel, Isaac, Audrey, Anthony,